Okay, so I just changed the title. I removed one line of code, so I've got 12 seconds per line of code. And yeah, that's Luna, and she wants you to come down with her into the rabbit hole. I don't know whether that's a promise or a threat, so let's find out. Okay, so first of all, you may know that bunnies love tunnels, but you may not know that they can cycle very fast. They can even travel back in time. The bunny's already around the corner. And they can fix C++ right from the start. So we're done. Okay, unfortunately, back to our timeline. So homogeneous variadic functions are functions or overload sets of functions that take an arbitrary number of arguments, but all of the same type. So there was a proposal for language support, but it was buried in Belfast in 2019. So let's look at our current best practice. That's parameter packs and requires. So we can ask a function to only take arguments that are convertible to a certain type T, and we can take any number of arguments. So there are no cons so far. Now let's assume we have two of such functions, one taking a bunch of ints and one taking a bunch of floats. And we call it with a bunch of ints, with a bunch of floats, and with a float and an int. So which overload gets called? So the problem is I wanted to make a poll, but in a lightning talk, that's pretty much time to waste. So I made up my own results. So here they are. So for the first function, a large majority goes for the int overload. For the second function, a large majority goes for the float overload, but they are not such convinced of floats than of ints. And for the third function, there's a pretty large amount that goes for ambiguous. And even watch at that yellow guy, I think he's at the wrong conference. So let's ask the compiler. Oops. So we see first function call ambiguous, second function call ambiguous, third function call also ambiguous. So why did that happen? Okay, let's analyze it. Both ints and floats are implicitly convertible to each other. The formal arguments are in both functions forwarding references, and the require clause is not part of the overload resolution. So with respect to overload resolution, both functions are totally identical. Okay, concepts won't help. She was in the future, she knows. So what can we do? We can merge the overloaded homogeneous variadic functions. We can put our types in an empty list. We can generate homogeneous test functions with the correct calls arity. We run built-in overload resolution, and we report the selected type back to the user, and of course as cons extra. So, and hey John, look, MP11 is used here. So let's go to the library. Okay, here are 25 lines of code, which is a complete library. And here we have our both overloads. We take ints and floats, and the first one here is the int overload, the second is the float overload. And now let's compile those two guys. We see the first function called the int overload, the second function called the float overload. And when we take into the third one, we get ambiguity and a compilation error as we wanted. So that's all. Go to my GitHub account, check out the hop library, which is built upon that stuff and can do a lot of more. And that's all rodents. And yeah, greetings to Ben's cabbies. Luna wanted to say that. Okay, I'm done.